Well, hello everyone. It's Mr. Curtis again, and today's Friday math activity is to add numbers, mixed numbers that can actually create a whole nother mixed number, a whole number. So our target for today is going to be understand and practice when a new whole can be created when added. Now, I want you to think. There's a lot of different ways to show the same value of numbers. Keep that in mind when dealing with fractions. We can represent fractions and any number for that matter in a variety of ways. Like 4 quarters is $1, 8 quarters is $2, and so on. In your notebook paper, I'm going to have you practice 4 problems as a review. You're going to go ahead and push pause, and then I'm going to go over the answers in just a moment. But go ahead and copy these problems down neatly in your notebook paper. Allow some room to work. Number 1 is 4 and 2/7 plus 3 and 3/7. Number 2 is 7 and 6/10 plus 5 and 2/10. Number 3 is 6 and 5/6 minus 1 and 2/6. And the final one is 10 and 4/5 minus 2 and 1/5. So go ahead, please push pause. I'm going to go over the answers in just a moment. Okay, I hope you guys worked hard on these problems as a review. Let's go ahead and check how you did. So remember, when we are adding fractions, we add the whole number separate from the fraction itself. So looking at my sevenths, 2/7 plus 3/7 is 5/7. And of course, the whole number looks like 4 plus 3 is 7. Number 2, I have common denominator, so yes, I can add. So if I have 6/10 and 2 more tenths, that would get me 8/10. And the whole number, separate from the fraction, 7 plus 5 gets us 12. 12 and 8/10. Now in subtraction, we have 6 and 5/6. Subtract 1 and 2/6. So I have common denominator, so I can go ahead and legally subtract. So 5 minus 2 is 3. And remember, the denominator doesn't change, so it's 3/6. And 6 minus 1 is the whole number, gets us a 5 and 3/6. Finally, we have 10 and 4/5. We're going to take the 4/5. They are common to the 1/5, so we can subtract. 4 minus 1 is 3, and the denominator stays the same. And 10 minus 2 is 8. So hopefully you did very well in those practice. Now let's go to a different concept, and it is when we add things together and we create a new whole. So Miss Rebecca went through her purse and her car, and she found a bunch of dimes and some cash. Well, how much money does she have in all? That should be in all. So first off, it's important to know that a dime is worth 10 cents, but a dime is also represented as 1/10. It would take 10 dimes to equal a whole dollar. A dime is worth 10 cents, but it's also a tenth of a dollar. Remember, we said there's a lot of ways to represent the same value? So what do we have here? Well, we'll go to the next page. So here's an actual representation. So you just, on the bottom of that paper you just did with the practice, let's go ahead and write this equation down. So this was 5 and 7/10 plus 2 and 3/10. Now, if you want to have them vertical, that's fine, or you can have them side by side. But let's go ahead and start adding the tenths or the dimes. Here we have 7 dimes or 7/10. So we'll put them over here, and we're going to add that to the 3 below, the 3/10. Since we can add dimes to other dimes, the denominators are the same. If we add those together, we actually get 10/10. 10 of the 1/10 value. And then we have to add our whole numbers or our dollars. And $5 plus 2 more is $7. So we have $7.10. Well, I want you to look at this right here and go, when our numerator and our denominator is the same, we can actually trade them or convert them for another whole. So let's assume this really nice lady is going to make us take our dimes for us, and we're going to go ahead and take all of our dimes, all 10 tenths, and we can turn them in, and she'll give us $1 back. 10 tenths is a whole. So how much money do we have now? Looks like we have 8 whole dollars, and there's no fraction left. 5, 6, 7, 8. So 7 and 10 tenths is equal to 8 whole. Finally, let's go ahead and talk about Coca-Cola. I love a good glass of Coca-Cola on a hot day. Maybe you do too. But let's consider each 6-pack a whole 6-pack. And how many cans of soda make up a whole 6-pack? That's right, a sixth. So here, let's say I have 3 whole packs, plus I have 4 sixths, because it takes 6 cans to make a whole 6-pack. So I have 3 and 4 6-packs. Over here, let's say in the cooler, I have a whole 6-pack left and 2 more sixths. What do I have in all? Well, let's go ahead and this time, let's just add the whole numbers first. So 3 packs, 1, 2, 3, plus the extra gives me 4. And then how many cans or fractions of a whole 6-pack do I have? Oops, there we go. It looks like I have 4 and 6 sixths. Well, that's important to know because we just learned a moment ago that if the denominator is the same as its numerator, that means we actually have another whole. So I can just move these and I can put them in a 6-pack. So how many total 6-packs do I have? If you said that we had 5 6-packs or 5 whole 6-packs, you're right. If you said we had 4 6-packs and 6 sixths, that's also right. So boys and girls, it's just important to know that when our numerator and denominator are equal, that means we have an extra whole set of something, whether it's cans or dollar bills. There's going to be a couple of questions we'd like you to do in the slides. We hope that this has been informative, and we can't wait to see your responses. Bye for now.